Welcome to Chapter 9. This chapter you're going to be looking at different ways that we can analyze data, different sets of data. This is also sometimes called statistics. In Section 9.1 that we're going to do in this video, we're going to take a look at scatter plots, which are ways of comparing two sets of data at once. Then we're going to look at lines of fit, and these lines of fits actually are going to connect with the scatter plot. So really 9.2 is going to be a way of analyzing 9.1. 9.3 is going to deal with two-way tables, which takes this type of data in here and groups it together in a table in a way that we can kind of do a lot of different things with how we analyze what's going on in the situation. And then finally 9.4 we're going to look at data displays, and this is reviewing a lot of things you've done in the last year or two, looking at box and whisker plots, stem and leaf plots, different types of bar graphs, line graphs, circle graphs. So let's start with 9.1, which is scatter plots. So a scatter plot is going to be a graph that shows cause-effect relationships between two sets of data that have a connection. And the idea is going to be looking at one of them causing the other. So we're going to look at a number of situations that deal with that. A scatter plot is actually going to be going to look like just a bunch of dots. And those dots are going to be scattered, and that's why it's called a scatter plot. One of the reasons we use scatter plots is to get a sense of how the data sets are related, and we're looking for what we call correlations, which means as we read the scatter plot from left to right, just as we read English, we're looking for what's happening to the y values, to the output values. If as we go from left to right and increase the input value, if it's a positive correlation, we're saying that that output value is generally increasing. Again, there may be outliers, but it's generally increasing. The negative correlation will be generally decreasing. Now the other two are going to be a little bit different. A nonlinear correlation is one where the points fall in a curve, and they may sort of curve upward, they may curve downward, they may do both. They may start out increasing a lot and then come back down again, or they may come down then go up, or they may just simply go up slowly but then speed up a bit like that. So that's nonlinear. Then the last one is no correlation, which means that the output value is unpredictable. As we increase the input value, the output values are going all over the place. They're going up, they're going down, and there's no way that we can predict what a given output value will be if we know the input value. As we look at a scatter plot and try to determine whether it's showing a positive, a negative, a nonlinear, or a no correlation, we may find some points on there that don't really fit the flow. They're points that they kind of seem like they're lost. They're not fitting in with sort of the general direction of the other points. And we call those points outliers because they lie outside the basic flow, so that in general points might be going up, but you may have a point that's over there, or they may be going down and you have a point that started out low to begin with. So we're not really going to be concern ourselves with that, and those are just considered exceptions to the general trend, and that's okay. So again, you often may find outliers. There may only just be one, there may be a couple, but you're going to look at it and you'll just instantly see, yeah, these points generally, the outputs get bigger as the inputs get bigger, or they generally get lower as the inputs get lower. And that's what we're looking for in correlations. We're looking for just general trends. So here are 6 examples of data sets that we could put in a scatter plot. And the way I've written these, the input value is always going to go first. So what we're asking is, as cars get older, what generally happens to their price? Does it generally go up, go down, or you really can't tell? And again, we don't concern ourselves with outliers. So if you find yourself, yeah, but what about, that's not really going to matter. We're not concerning ourselves with the exceptions. We're concerning ourselves with general trends. And the reason I put it in this order here with the age of car first is that you want to ask what causes something to happen. So does the age of the car cause the price to go up, or does the price going up affect the age of the car? And so that's why we always are going to put these in a cause-effect relationship where when we write it, this first data point will be the X and the second will be the Y. And that's going to be true throughout this entire list here. So the second one, as the price of cars increase, what happens to the number that you sell? The third one, as candy bars get older, what happens to their price? The fourth one, as candy bars get bigger, it doesn't mean an individual candy bar getting bigger, but as you start looking at larger and larger candy bars, what happens to the number of servings you get? Fifth one, if we got the data of all the people who were alive in 1930, right, the babies and the old folks, everybody, and we looked at, in general, if we got the information for how many years did they live after 1930, right? In general, if we look at the older people, are they living longer or shorter number of years after that? And then the last one, we're going to talk about the number of years of education that a person has had, the 30-year-old person has had, and what their income is. So what I want you to do right now is pause the video and write down what you think would happen. And so this is sort of multiple choice for each one. So your answer for each one is either going to be, what I want you to write down is it going to be positive? Is it going to be negative? Or will there be no correlation? So for the first one, in general, as cars get older, the price of them will decrease. And so we would call that a negative correlation. Yes, there are vintage cars, but those would be the outliers. We're looking at in general, right? So if I tell you, hey, my car is 10 years old, and another teacher says, hey, my car is 3 years old, which car would you expect to be worth more? So again, if we took all the 3-year-old cars, all the 5-year-old cars, all the 10-year-old cars, in general, you would see that wave of dots going downward. So look at the next one. We've got the cost of a car and the number sold last year. So in general, would you expect as cars go up, that the cost of cars goes up, that the number of cars would go up, down, or stay the same? No prediction. And in general, they're going to go down. So we're going to call that, and again we're looking at general right now, in general, that's going to be negative. Look at the third one. The age of a candy bar and the price of a candy bar. Well, think about when you buy candy bars. Do you really look at the price of them? Yes. Do you look at the age of them? No. So in general, would the age affect the price? No. So we're going to call that no correlation. Fourth one, though, in general, as candy bars are bigger, do you get more servings out of them? And in general, yes, so we call that positive. The age of a person in 1930 and the number of years lived after that. In general, we would expect a negative correlation. In general, we would expect that the 20-year-olds in 1930 lived longer than the 50-year-olds did. And then the last one, years of education and income at age 30. In general, what statistics show, data analysis shows, is that people who have more education usually earn more money, so we would call that a positive correlation. So in this scatter plot, see all the dots? See how they're scattered? It's a scatter plot. What we're looking at is, in general, if the temperature on a given day is warmer, would we expect, and remember we're talking about predictions here, would we expect the number of people going to the beach to increase, to decrease, or that there be no prediction? So what we're asking is, okay, if I know that it's going to be 92 degrees outside today, will I expect the beach to be more crowded, less crowded, or who knows, than it would be on a day where it only gets up to 84. So this one is going to show positive correlation, which means that in general, as the temperature if the temperature gets higher, also the number of visitors will get higher, and so that's positive correlation. and you can see what happens. In general, the dots are going upward. Now, do you see any dots that you would consider to be an outlier? See, I see one, and it's this one right here, where for some reason on that day, even though the temperature was 87 degrees, not many people went to the beach that day. Why not? Well, who knows? There may have been some big event going on. We don't know, and we really don't care. What we're looking at is, in general, we have this sweep that's going up and to the right. As the temperature is increasing, the number of visitors is increasing. And again, this would be your outlier. Yes, it's valid data, it's not a myth, but it also really has no effect on our decision about what kind of correlation there is. So here's a graph that is going to show you the winning percentage of each baseball team and how many people attended the game, and again saying their average attendance on it. So what it's showing you is that this is 50%, this is 60%, this is 35%, only, winning only about a third of their games here. And what we're looking at is, as if the team is winning more, does that affect the attendance of the game? Now this is a really important graph to look at, because if we switch this, and if we had put the attendance down on the bottom and we had put the winning percentage over here and changed the input-output, we'd be asking a different question. We'd be asking, hey, if more people go to the game, will our team win more? And that's not the question here. The question is, if a team is more successful on the field, does their attendance go up, which means are they making more money? And so look at this. Would you call this in general positive, negative, or no correlation? To me, it's positive correlation because in general, we have this sweep going upwards. Do you see any outliers? I see a couple. I see the New York Mets right here that really had a lot of loyal fans, even though they weren't really winning very much. They're winning less than half their games, but they've got some pretty loyal fans there. And then I also see an outlier down here, Florida, where even though they're a pretty successful team, they're not getting many fans. So those are the outliers. But in general, the teams, as they become more successful, they're bringing more people into the stadium. So here's an example of negative correlation, which is showing that in general, students who missed classes for whatever reason, whether they were sick a lot or just not motivated, and how they did on their tests, that in general, students who miss more classes tend to get lower scores on the tests. Do you see any outliers? Well, let's take a look. There's this one right here, but that wouldn't really affect anything. That's just someone who really did poorly. That didn't affect much as we do that. If we look anywhere else, though, in general, no real outliers here. So we call this one a negative correlation. Right here. This one's negative. So finally, here's one where this is a graph of something we would call no correlation. It's asking, in general, do students who are taller have higher grade point averages? And you look at it, and they're all over the place. And you can see there's a line here, which we're going to get to in section 9.2. And that's sort of a line where the points sort of are kind of split by that line if you look at it. It's pretty even in terms of how many points are here, how far away they are. Are there any outliers? Yeah, there's this point right here, which is way out of there, but again, that's not going to matter. So again, so if someone is a taller student, it doesn't mean that they're going to earn a higher grade point average or a lower grade point average. It's pretty much all over the place. So those are the three types of correlation. So now go to the Edmodo group, do the homework problems that go with 9.1, check your answers as always, ask any questions as always before you move on to 9.2.